I'll begin by recording. Now we're on record. Now, before I continue, I would like to find out if I'm audible enough. Can you people hear me?
Yes, please.
All right, great. So let me share my screen. Today we're looking at deductive reasoning. Now, welcome to the second half of the semester. The first half was a preparation. Like I told you before, we were studying concepts in language and meaning. We were looking at statements that are not logical. You remember we discussed metaphors, proverbs. We learned how to identify passages that are argumentative or not. Now it is time to study arguments. And I have to tell you that this is the most challenging topic in this semester, in this course. So I'll advise you to listen very attentively. And then I will also try to break it down as meticulously as possible. Okay. So we're going to take it step by step so that you understand it very well. Now we're beginning our study of arguments. Up until now, we've been doing English language like you did in your primary and secondary schools. That was no challenge at all. Now we're beginning our classes in logic. Different forms of reasoning. Arguments are also called reasoning or syllogisms. That is, when we argue, we are reasoning. And then our arguments are also called syllogisms. So we'll be using the three terms interchangeably. Now, there are two major categories of reasoning. We have deductive and inductive. This class is for deductive reasoning. We also have causal reasoning, but it's a form of inductive reasoning. Now, deductive reasoning is also called deductive argument, deductive syllogism. This is reasoning in which the relationship between the premises and the conclusion is a logical relationship. The relationship between the premises and the conclusion is a logical one. So because of this, it is reasoning that permits only one conclusion. It permits only one conclusion. When the relationship between in a process, when a particular procedure is logical, you can only have one outcome. It is just like a mathematical operation. If you have 2 plus 2, you have only 4. You can't have 4 and another number. That's why we say it permits only one conclusion. And this is particular to deductive reasoning. Example, all men are mortal. Kofi is a man. Kofi is mortal. Now, if you say all men are mortal and you also say Kofi is a man, the only conclusion would be that Kofi is mortal. There's nothing you can do to change this conclusion or to oppose it. You cannot change or modify the conclusion to say Kofi is immortal or a fire cabinet is mortal. Okay, so let me make one more comment, and that is why we say it is deductive argument. When you go to inductive reasoning, it's not the same. An argument can permit more than one conclusion. You can oppose it and all that. But deductive arguments are mathematical arguments. They are like mathematical operations. They give you only one conclusion. Otherwise, the argument will be invalid. Okay, reference and attribute classes. Now, before we start our class on deductive reasoning, we need to look at the two parts of a sentence in an argument or in logic. the two parts of a sentence in an argument. Just like we saw the subject and the predicate in our English classes. Remember that when we did definitions, we had seen two parts of the sentence in definitions. We had seen definiendum, which is like a subject, and we had seen definiens, which is like predicate. Now we are doing reasoning, deductive reasoning. There are two parts of a sentence. We have the reference class, which is like a subject, and we have the attribute class, which is like a predicate. For example, all men are mortal. Now, in the sentence, all men are mortal, all men is the reference class. Are mortal is the attribute class. The reference class is that to which the sentence refers. So it is simple. The reference class is that to which the sentence refers, whilst the attribute class is that part of the sentence that is attributing something to or saying something about the reference class. So all men is what the sentence is referring to, all men. That's why all men is a reference class. And then something is being said about all men. The sentence is saying that it is being referred to, or rather, the sentence is saying that all men are mortal. So are mortal is what is being said about all men. So whilst all men is the reference class, are mortal is the attribute class. Now let's look at reference class. We have two kinds of reference classes. We have the finite and infinite reference classes. So what is the finite reference class? What is the infinite reference class? The infinite reference class refers to all members or no members of a class, either 100% or 0. Example, all men, no man, any man. So infinite reference class, it is either all members or no members of a class. But and that is why we say it is infinite. You can't count all men. You can't count all men. You can't count any man. So it is uncountable. We say it is the uncountable reference class. That's why we call it the infinite reference class. All men, no man, any man. But the finite reference class refers to countable and particular members of a class. Anything between 0% and 100% is countable. And that falls into the finite reference class, the countable reference class. For example, some men is countable. 80% of men, that's countable. 5 men is countable. 1 man is countable. All the men is countable. Now remember that all the men is different from all men. All men is not countable, but all the men are countable. Usually when you say all the men, you are saying all the men in a particular context. All the men in this class, all the men in the university, all the men in Accra, they are countable. But when you say all men, it is not countable because all men would include all men who have existed, and then those who are yet to exist, who are yet to be born, it is infinite and uncountable. Okay, so that's the difference between the countable reference class and the uncountable reference class. The uncountable reference class refers to all members or no members of a class. The countable reference class refers to anything between 0% and 100% of the class. Now then there's universal and particular statements. Statements containing the infinite reference class, that is the uncountable reference class, are called universal statements, whilst those containing the finite reference class are called particular statements. So example of universal statements, all men are mortal. All men are mortal, universal statements. It contains the infinite reference class. Example of particular statements. Some men drink alcohol. Some men drink alcohol. That's a particular statement because it contains the countable reference class, the finite reference class. Exercise. Which statements are universal and which are particular? So which statements are particular, which are universal? This table is three-legged. Can anyone answer that?
Sir, please, it is particular.
It's particular.
The next one.
The particular.
Universal.
Universal.
Sir, please, universal.
The next.
It's particular.
Particular.
And the next.
Particular.
Universal.
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 Okay, that's fine. So let's move on. Let's quickly move on. Quickly, because we have a lot to understand today. Then let's look at validity. This is another important issue to clear up. Validity. An argument is valid if the premises make the conclusion necessary and the conclusion follows with certainty. Look at it again. An argument is valid if the premises make the conclusion necessary. That is, when you have a set of premises, then you see that a particular conclusion must follow, and the conclusion follows with certainty. There is no question what is the conclusion. There can be no other conclusion. And in fact, the conclusion is a must. If you have 2 plus 2, there's a particular conclusion must follow. There's no argument. We don't waste time about what it is. If it's 2 plus 2, then it must be 4 must be the case. That's why we say an argument is valid if the premises make the conclusion necessary and the conclusion follows with certainty. Any argument where the conclusion doesn't follow with certainty, and this is what you have to note when we get into types of deductive arguments. In order to be able to know a valid deductive argument or not, you have to ask yourself whether the conclusion follows with certainty. Once it is clear to you that the conclusion doesn't follow with certainty, then that argument is not valid. We shall be doing that exercise in a few minutes. So the conclusion must follow with certainty. Now let's move on. All valid arguments are deductive arguments. So inductive arguments are strictly not valid. So only deductive arguments are valid arguments. So a deductive argument is a purely mathematical argument in which the relationship between the premises and conclusion is logical. Okay. Now, so talking about validity, let me look at this example again. We said all men are mortal. Kofi is a man. Kofi is mortal. So this argument is valid because the conclusion follows with certainty. The premises make the conclusion necessary. Now, I want to show you a particular mathematical operation in this argument so that you see why the conclusion is necessary. Now, when you look at premise 1, you see 2 terms. You see men and you see mortal. Premise 1 contains 2 terms, men and mortal. Premise 2 contains an additional term, a third one, which is Kofi. Premise 2 contains a third term, someone's name, Kofi. And it also contains man. Man is already a term in premise 1. So premise 1 contains 2 terms, men are mortal. Premise 2 contains a third term, Kofi, and a repetition of 1 term in premise 1. So the term men already appears twice in premises 1 and 2. Premises 1 and 2, when you look at the 2 premises, men appear twice, mortal appear once, and Kofi appears once. I want to repeat that. Premises 1 and 2, surveying all the premises available, 1 and 2, you see that men appear, the term man or men appears twice, mortal appears once, and Kofi appears once. What does that suggest? It suggests that the conclusion should be made up of only those terms that have appeared once. So you get the terms that have appeared once in premises 1 and 2, and those terms are going to form the conclusion. What are the terms that appeared once?
Mortal.
Please, Kofi and mortal.
Kofi and mortal.
Kofi.
So Kofi and mortal is going to form the conclusion. Kofi and mortal will form the conclusion. And when they are forming the conclusion, which of them is going to be the subject or the reference class? And then which one is going to be the predicate or the attribute class? We already have 2 terms. So we have to arrange them to form the conclusion. One is going to be the subject and one is going to be the predicate. When you look at premises 1 and 2, all men are mortal. Premise 1, all men are mortal. Premise 2, Kofi is a man. Premise 2 will show you which term is going to be the subject or the reference class of the conclusion. Now, Kofi is a man. So the conclusion is supposed to be about Kofi. The conclusion is supposed to be saying something about Kofi. So Kofi is going to be the subject or the reference class of the conclusion. So the conclusion would be Kofi is mortal. So first of all, when you look at an argument, a deductive argument, you check the terms that have appeared twice, and then get those that have appeared less than others. They are going to give you the conclusion, the next conclusion. And then when you've gotten the 2 of them, you ask yourself which of them is going to be subject and which is going to be the predicate of the conclusion. To find out which is going to be the subject, you look at the premises again and ask yourself, what kind of conclusion is the premises trying to reach? In this particular argument, you see that the premises are suggesting that the conclusion should be something said about Kofi. All men are mortal, Kofi is a man. Therefore, what? Therefore, can you say mortal is Kofi? You can't say mortal is Kofi. All men are mortal, Kofi is a man. Therefore, Kofi is mortal. So premise 2 suggests what the conclusion should be talking about. The conclusion is supposed to be talking about Kofi. So now that answers your question about what the conclusion is. You've gotten the 2 terms that will make the conclusion, and you've also seen which of the terms is going to be the subject and which one is going to be the predicate. That tells you that it is a purely mathematical operation. It's just mathematics using words, All right. So let's go back to where we stopped. We've seen the issue of validity. And we were saying that an argument is valid if the premises make the conclusion necessary and the conclusion follows with certainty. And we said all valid arguments are deductive arguments. So once you have performed the mathematical operation, you've gotten the terms that will form the conclusion, and you've arranged the terms to make the conclusion, and the mathematical operation is complete, then it means you have constructed a valid argument. Such an argument is valid. And it is only a deductive argument that can be like that. So all valid arguments are deductive arguments. Inductive arguments are strictly not valid. A purely mathematical argument, the relationship between the premises and conclusion is logical. So now let's compare it to an inductive argument. And now we see why deductive arguments are valid. This is an inductive argument. 95% of men are honest. Peter is a man. Peter is honest. Now, we said that for an argument to be valid, the premises make the conclusion necessary, and the conclusion follows with certainty. So looking at this argument, do you think the conclusion follows with certainty?
No, please.
No, please.
Okay, so why does the conclusion not follow with certainty?
Say,
Yes.
please, you said as when you compare this with the first one, you were like in the premises, the first and the second, we are supposed to have the same word in both premises, whereby to give us the conclusion. But in this case, you are not having same words which are appearing to in both premises, which makes it no.
Yes, that one, even that one applies to this. Now, in the premise one, you have men and honest. You have two terms in premise one, men and honest. Premise two, you have Peter, which is a third term. You have man, which is a repetition of premise one. So you eliminate men, and then you are left with honest and Peter. So you use Peter and honest to form the conclusion. So, and Peter has to be the subject. So the conclusion says Peter is honest. But there is something. Now, there is something in the premises that shows you that the conclusion cannot follow with certainty. There's something else that
Sir,
shows you, yes,
Sir, please, the 95%.
95%.
the 95%. So
Yes,
when
please.
look at the 95% of men are honest. Peter is a man. Peter is honest.
Yeah.
So you see
Sir.
that 95% of men are honest. Peter is a man. Peter is honest. Yeah, so you see that the conclusion doesn't follow with certainty. Peter could be among the 5% that are dishonest. You know, so more than one conclusion is possible. In fact, you should have two possible conclusions. Possible conclusion one, Peter is honest. Possible conclusion two, Peter is not honest. This is how you identify an inductive argument. If you look at the argument and you realize that the conclusion doesn't follow with certainty, then it cannot be a deductive argument. It's an inductive argument. All right, so let's go on. Now, this is where we begin the real, what do I call it? The real technicalities, the hidden conditional if and then. Now, we often make statements that contain what we call conditionals. If then, if this happens, that happens. If this, then that. If I'm hungry, I'll eat. If the weather is cold, I'll put on thick clothes. If the university, if the lecturers goes on strike, I'll go home. If there is an invasion, I'll run out of the country. If this, then this, you know, they are called conditional statements. If then statements are conditional statements because the if is a condition for the then. You know, you are given a condition for something. If it's a condition, and then is what will happen once the condition is met. Okay. Now, all arguments have hidden conditionals. All arguments have hidden conditionals. For example, let's look at this categorical statement. All men are mortal. All men are mortal. If you are asked to convert this categorical statement to a conditional statement, what will it be? For a conditional statement, it will say, if something is a man, then it is mortal. If you want to convert all men are mortal to a conditional statement, then you have to bring in the if and then. So how do you reformulate the argument to become an if-then statement? All men are mortal. If something is a man, then it is mortal. So that's the conditional version. Okay. Change the conditional statement of premise 1 to a conditional, change the categorical statement of premise 1 to a conditional statement. So let's go back to our argument. All men are mortal, Peter is a man, Peter is mortal. So you change the premise 1 to a conditional statement. So premise 1 was reading all men are mortal. So premise 1 changes from all men are mortal to if something is a man, then it's mortal. Premise 2 and conclusion remain the same. Now, when you look at this new argument or this new form of the argument, you see the argument, you begin to see how the argument moves. That is, it helps you to see the argument more clearly. If something is a man, then it is mortal. Peter is a man, therefore Peter is mortal. So changing the major premise in an argument to a conditional helps you to see the structure of the argument much more clearly. And then when you are looking at an argument, which of the statements should you change to a conditional? Which of the statements should you change to a conditional? Let me go back to the original argument. Okay, now this is the original argument. All men are mortal. Kofi is a man. Kofi is mortal. How do you change this argument to a conditional version? Which of the statements are you going to change to a conditional? There must be one of them. I want to show you how to detect it. There is just one statement that you change to a conditional and the rest will be the same.
Sir, please, the premise 1.
The premise 1, yes. So why are you able to change premise 1 to a conditional?
President, don't forget
Sir, because it contains the class to be under discussion.
Yes, and then when you look at premise 1, you see that it refers to all men. It refers to all men. So because it refers to all men, you see that you can say if something is a man. If something is a man, then it is mortal. All men are mortal. If something is a man, then it is mortal. When you look at premise 2, you see that you cannot change premise 2 to a conditional. Premise 2 is not a material for a conditional. It just says Kofi is a man. You can't say if something is Kofi, then it is a man. Because not all Kofi, if something is Kofi, is a man. But it's not a general statement about, Kofi. It's not about Kofi being, it's not about all Kofis. It's about a particular man who is Kofi. But when you look at premise 1 is talking about a collection of items. It's about all men. So you see that premise 1 is the one you can convert to a conditional, not premise 2. Okay, now if you can convert premise 1 to a conditional, I normally say that premise 1 is the major premise. I call it the major premise. It's not in the textbook, but I call it the major premise. So once you have identified the major premise, it is the premise that you can convert to a conditional statement. And by the time we progress, you see that that is the premise that you'll be using for most of your operations. When we start going into all the kinds of deductive arguments, you see that the major premise is where you start all your calculations. You need to identify which one is the major premise. It is not the same as the other premises. So I just wanted you to have it at the back of your mind. The major premise is the one you can change to a conditional statement. And then when you look at premise 2, premise 2 is saying something about premise 1. Premise 2 is referring to premise 1. You notice that premise 1 is making a general argument, but premise 2 is referring to premise 1. So that tells you that premise 2 is like a subordinate or some kind of servant who is serving a master. Premise 2 is like a servant serving a master. But premise 1 is making a general argument. You know, premise 1 is like the employer and premise 2 is like the employee. So those are the things that will tell you that which one is the major premise. Okay. Okay, so now we can see the conditional version of the argument at the bottom of this slide. Instead of all men are mortal, we have if something is a man, then it is mortal. Peter is a man, therefore Peter is mortal. So sometimes we need to change an argument to its conditional form so that we can see what it is actually doing. It is when we get to a more complex stage that we understand that. Now let's replace the argument with symbols. Look at the categorical version. All men are mortal. Oh, sorry, there's a mistake there. All men are mortal. Peter is a man. Peter is mortal. Now replace men with A, and then replace mortal with B. And then there are only 3 terms. You just have men, mortal, and Peter. So men will be A's. Mortal will be B's. Peter will be X. Peter will be X. So all men are mortal, all A's are B's. Peter is a man, X is an A. Remember that man is A, so a man is A. Peter is mortal, X is a B. So in symbolic form, all A's are B's, X is an A, X is a B. Okay. Now let's change it to a conditional. If something is a man, then it is mortal. Peter is a man, Peter is mortal. Look at the symbolic version. If A, then B. If A, then B. X is an A, therefore X is a B. Although you know that, for summary purposes, we can just eliminate the X is for premise 2 and conclusion. If A, then B, X is an A, X, therefore X is a B. Or if A, then B, A, therefore B. If A, then B, A, therefore B. So this shows you that we are just doing mathematics. Now let's make this distinction. This is the distinction with which we do deductive arguments. All our operations are based on the distinction between antecedents and consequence. So antecedents and consequence is what will show us how deductive arguments operate. Now let's remember that we talked about reference class and attribute class. And we were saying that the reference class is like the subject, the attribute class is like the predicate. Now, And we also converted categorical statements to conditional statements. We said all men are mortal. For conditional, it is if something is a man, then it is mortal. Now, bearing in mind those two lessons, the lessons about classes and the lesson about conditionals. So let's look at the second sentence here. If we restate any categorical proposition as a conditional statement, that is, if we convert from categorical to conditional, the reference class of the conditional becomes the antecedent, and the attribute class of the conditional becomes the consequent. Now, remember we said all men are mortal. If something is a man, then it is mortal. If something is a man, is the what? Is a reference class. Then it is mortal, is the attribute class. When you look at all men are mortal, all men is reference class, and mortal is attribute class. When you have converted it to conditional, all men becomes if something is a man, from all men to if something is a man. So both of them are the reference class. And then when you convert it to conditional, a mortal becomes what? Then he is mortal. If something is a man, then he is mortal. So a mortal becomes then he is mortal. Both of them are the attribute class. And it is the same with this example here. Example, all A are B, or if A then B. The reference class, in this case A, is the antecedent. So all A are B, or if A then B. A is the reference class. B is the attribute class. The reference class is normally called the antecedent, and the attribute class is normally called the consequent. So A is the antecedent and B is the consequent. So let me go back. All men are mortal. Kofi is a man. Kofi is mortal. When you look at premise one, all men are mortal. The reference class is normally the antecedent. The attribute class is normally the consequent. So whether it is in categorical form or it is in conditional form, the reference class is the antecedent and the attribute class is the consequent. Of course, you know that antecedent comes before consequent, and antecedent means before, and then consequent means after. Okay, so all A are B, or if A then B, the reference class is the antecedent and the attribute class is the consequent. So A is the antecedent and B is the consequent. So any statement referring to A will be either affirming or denying the antecedent. So this is what you need to take seriously. Any statement referring to A will be either affirming or denying the antecedent. And any statement referring to B will be either affirming or denying the consequent. So all men are mortal. Any statement referring to men is either affirming or denying the antecedent. And any statement referring to are mortal is either affirming or denying the consequent. So you remember that premise two says something about premise one. Now let me take you back. I was telling you that premise two says something about premise one. And I was telling you that premise two is like a servant who is serving a master. The master is premise one, the servant is premise two. Premise 2 is saying something about premise 1. Now, you can see that in this case, premise 2 is saying something about men. Premise 2 is saying something about men in premise 1. Premise 2 is telling you that Kofi is a man. It's identifying a particular thing in the world as a member of the category all men. So now, if all men is the antecedent and mortal is the consequent, then it means that premise 2 is saying something about, it's not just saying something about premise 1, it is specifically saying something about the antecedent. So we will say that premise 2 is saying something about the antecedent. The conclusion is saying something about the consequent. The conclusion is Kofi is mortal. So the conclusion is saying something about the consequent. Premise 2 is saying something about the antecedent. Conclusion is saying something about the consequent. Do you understand that?
Yes, please.
Okay. So that is very important. Now let's go back to. Okay, so look at the last statement on this slide. Or the last two statements. A is the antecedent and B is the consequent. So any statement referring to A will be either affirming or denying the antecedent. And any statement referring to B will be either affirming or denying the consequent. Now let's look at this. X is an A, affirms the antecedent. X is not an A, denies the antecedent. X is a B, affirms the consequent. X is not a B, denies the consequent. Now, the example, I don't want to go back to that example. All men are mortal, Kofi is a man, Kofi is mortal. Now, but when you look at that original argument, Kofi is a man, is actually affirming the antecedent. Remember that the antecedent is all men. So when the second premise says Kofi is a man, it means the second premise is not just saying something about the antecedent, but it is affirming the antecedent. Look at the examples here. X is an A, affirms the antecedent. X is not an A, denies the antecedent. X is a B, affirms the consequent. X is not a B, denies the consequent. Okay, so let's look at an argument that affirms the antecedent. This is an example of an argument that affirms the antecedent. Now, the major premise, all A's are B's. That's the major premise. The second premise, X is an A. You notice that the second premise is saying something about the antecedent of the major premise. And remember that it is the major premise that you break down into antecedent and consequent. Okay, so the second premise is saying something about the antecedent of the major premise. And normally, you don't normally say it is antecedent of the major premise. You just say it is the antecedent of the argument. So the second premise is saying something about the antecedent. And the second premise is affirming. It is affirming the antecedent. It is telling you that X is an A. So it affirms the antecedent. Because of that, we'll say that the whole argument is affirming the antecedent. Now, when the second premise says X is an A, it uses it to reach a conclusion that X is a B. So any argument that affirms the antecedent in order to reach a conclusion is an argument that affirms the antecedent. We don't just say that premise 2 affirms the antecedent. We say that the whole argument affirms the antecedent. Denying the antecedent. All A's are B's, X is not an A. Therefore, X is not a B. So you see that the second premise is denying the antecedent. Because of that, we'll say that it is an argument, the whole argument denies the antecedent, or it is an argument that denies the antecedent. Affirming the consequent. All A's are B's, X is a B. So the second premise is saying something about the consequent, and it is actually affirming the consequent in order to reach a conclusion about the antecedent. X is a B, therefore X is an A. Now, so this argument is affirming the consequent in order to reach a conclusion. So we say that the whole argument affirms the consequent, or it is an argument that affirms the consequent. Denying the consequent. All A's are B's. X is not a B. Therefore, X is not an A. So, because the second premise is denying the consequent, we say that the whole argument is denying the consequent, or it is an argument that denies the consequent. Now, this is the rule for deductive reasoning. This is the rule. We only affirm the antecedent and deny the consequent in order to reach a valid conclusion. We only affirm the antecedent and deny the consequent in order to reach a valid conclusion. Any other operation would make the argument lose its validity. So what it means is that going back, out of these 4 arguments we saw, only 2 of them are valid arguments. Now, so the rule says we can only affirm the antecedent or deny the consequent to reach a valid conclusion. Now, this is an argument that affirms the antecedent. All A's are B's, X is an A, therefore X is a B. So this argument is valid. The next one is not valid. This one denies the antecedent, so it is not valid. Then you come to the ones about consequence. This one affirms the consequent. It is not valid. This one is denying the consequent. It is valid. So out of the 4 operations, only 2 are valid. The other 2 are invalid, and we will find out why. So that is why we say for the rule, we only affirm the antecedent and deny the consequent in order to reach a valid conclusion. Just memorize it right now, because we'll be using it to find out which deductive arguments are correct and which ones are not. We only affirm the antecedent and deny the consequent in order to reach a valid conclusion. Now let's find out why it is so. So all A's are B's, X is an A. This affirms the antecedent. X is a B. It's a valid argument. All A's are B's. X is not an A. It denies the antecedent. So X is not a B. It's not a valid argument. Convert it to words. All Ghanaians are Africans. Peter is a Ghanaian. It affirms the antecedent. Therefore, Peter is an African. It's a valid argument. Why is it a valid argument? Now, you say all Ghanaians are Africans. So everyone who is a Ghanaian is included in the identity Africans. And then you said Peter is a Ghanaian. So definitely, because all Ghanaians are Africans, Peter should also be an African. That's why it is a valid argument. Look at the box here. Now, this is Africans, this is Ghanaians. There are 2 boxes. There is a big box. There is a small box inside the big box. Now, the small box is the box of Ghanaians. The bigger box is the box of Africans. So we said all Ghanaians are Africans. So everyone who is a Ghanaian is in the identity of Africans. That's why the small box is in the big box. If you identify anyone as being in that small box, it means that automatically that person is also in the bigger box. Let me repeat it. Anyone who is in the small box is also automatically in the bigger box. So if you say all Ghanaians are Africans, Peter is an African, therefore Peter is, sorry, all Ghanaians are Africans, Peter is a Ghanaian, therefore Peter is an African. The argument is valid. So you use this kind of illustration. Now, the explanation is that the consequent is always bigger than the antecedent. The consequent is always bigger than the antecedent. So when you say all A's are B's, B's are always bigger than A's. Let me repeat it. When you say all A's are B's, it means the B's are logically bigger than the A's. The A's are to be included in the B's, but the B's can contain both the A's and much more. Do you understand that?
Yes, sir. Please.
Yes, sir.
Is there anyone who doesn't understand that? Because if you don't understand it, you are going to fall into a trap, and you can be in that trap throughout your life.
Sir, go over again.
When you say all A's are B's, when you write a sentence that all A's are B's, I'm telling you that the B's, the B's as a category is a bigger category than the A's. When you say that this is a part of this, or when you say all A's are B's, the B's are a larger class of items than the A's. The A's can be contained in the B's, but I'm telling you that the B's can contain the A's and also contain possibly more. That is why you say that if you say all Ghanaians are Africans, the Africans are a larger class of items than the Ghanaian class. So the class Africans can accommodate the class Ghanaians, and it can also accommodate more. So we say that the consequent is normally a larger class, a larger size of items, or a larger class of items compared to the antecedent. Consequents are normally larger classes than antecedents. That is the rule that you'll be operating with. Okay, so let's go back to our first argument. So we said all Ghanaians are Africans. Peter is a Ghanaian, Peter is an African. So it's a valid argument because the box Ghanaian is inside the box African. So anyone who is a Ghanaian is automatically in the box of Africans. Okay, look at this. Look at the second argument. All Ghanaians are Africans. Now, but remember that this first argument is an argument that affirms the antecedent. And we said it is a valid argument. So you can see why an argument that affirms the antecedent is a valid argument. When you say all Ghanaians are Africans, Peter is a Ghanaian, affirming the antecedent. Peter is an African. It gives you a valid argument. But if you say Peter is not a Ghanaian, in order to say that Peter is not an African, it will not be a valid argument. Let's look at that's what is below. All Ghanaians are Africans. Peter is not a Ghanaian, which denies the antecedent. Peter is not an African. We say this is not a valid argument. Now, so we'll go back to the boxes so that we'll see why it is not valid. All Ghanaians are Africans. Peter is not a Ghanaian. Peter is not an African. Why is it not a valid argument? Let's go to the box. This is Africans, this is Ghanaians. We said all Ghanaians are Africans. Peter is not a Ghanaian. Peter is not an African. Now, when you look at these two boxes, if you say that Peter is not a Ghanaian, can you use it to reach the conclusion that Peter is not an African?
No,
No,
sir.
please.
Why?
Because he could be a Nigerian, which means he's an African.
Yes, he could be outside the Ghanaian box. He could be outside the Ghanaian box in any other part of the African box. Look at the African box is large. It's larger than the Ghanaian box. So he could be anywhere apart from the Ghanaian box. And he's still in Africa. So if you say all Ghanaians are Africans, Peter is not a Ghanaian, therefore Peter is not an African, the conclusion doesn't follow with certainty. So any argument that denies the antecedent cannot give you a certain conclusion.
Okay.
If you make an argument that denies the antecedent, it cannot give you a valid conclusion, a conclusion that follows with certainty, because the consequent is larger than the antecedent. So you cannot exclude someone from the consequent by simply excluding him from the antecedent. The Department of Chemistry is inside the University of Ghana, and the Department of Chemistry is smaller than the University of Ghana. So you cannot exclude somebody from University of Ghana by simply excluding her from Department of Chemistry. But if you included her in Department of Chemistry, automatically you have included her in University of Ghana. That is why an argument that affirms the antecedent is a valid argument, but an argument that denies the antecedent cannot be valid. Okay, so any argument that affirms the antecedent is valid. Anyone that denies the antecedent is not valid. Now let's go to the ones about consequence. Okay, so before we go to the one about consequence, let me see. This is the technicality I've been trying to explain. Now, this is what we just did. All Ghanaians are Africans. Peter is not a Ghanaian. Peter is not an African. So we just saw that it is not valid. It is only the one that affirms the antecedent that is valid. Now, the technicality is that the consequent is always a larger class of denotations or members compared to the antecedent. The consequent contains the denotations of both the antecedent and possibly more. So the consequent Africans contains more members than the antecedent Ghanaians. When you deny something of membership in a smaller class, you have not denied it of membership in a larger class. But when you deny something of membership in a larger class, containing all the members of a smaller class, you have automatically denied it of membership in a smaller class. So let's go back to, now this is Africans and this is Ghanaians. Let us consider an argument that denies the consequent. Peter is not an African, therefore Peter is not a Ghanaian. So now we are trying to either deny or affirm the consequent instead of the antecedent. Now, if you say all Ghanaians are Africans, Peter is not an African. Therefore Peter is not a Ghanaian. Is it a valid argument?
Yes, please.
Okay, so why is it valid?
Please, since it has been denied in the as in Africans.
Yes.
He's saying Peter is not an African, so automatically he can't be a Ghanaian because he has been denied in the.
Yes, so that's correct. Yeah, so that's correct. If you say someone is not an African, then it means he is not anywhere in the box. You can't say someone is not an African and then you say he's in the Ghanaian box. So if you say all Ghanaians are Africans, Peter is not an African, therefore Peter is not a Ghanaian, it's valid. If you say someone is not an African, then automatically the person cannot be a Ghanaian. So any argument that denies the consequent is a valid argument. Any argument that denies the consequent is a valid argument. That is why the rule of deductive reasoning says that you can only affirm the antecedent or deny the consequent in order to reach a valid conclusion. Any other operation is invalid. Okay, let's try to affirm the consequent and see what happens. Now, you say that all Ghanaians are Africans, Peter is an African, therefore Peter is a Ghanaian. Is it a valid argument?
Sir, please, the question again.
Yeah, if you say all Ghanaians
No,
are
sir.
Africans, if you say all Ghanaians are Africans,
No.
Peter is an African, therefore Peter is a Ghanaian. Is it valid?
No, sir.
No,
It's not
sir.
Sir,
valid.
please, it's not valid.
Okay, so why is it not valid?
Because
Because him being an African
Because
doesn't
being an
necessarily mean that
African
he's a
doesn't
Ghanaian. He could be
he can also
from
be
any
from
other
another
country.
country.
put you in Ghana. You can be an African and be in
Another
Togo
Other
or
country.
Benin.
Yeah, so that's correct. That's correct. That's correct. So you can see the argument is not valid.
Mm.
So that means that any argument that affirms the consequent is not a valid argument. Any argument that affirms the consequent is not valid. So now we have seen 4 types of arguments. We've seen that the argument that affirms the antecedent is valid. The one that denies the antecedent is not valid. We have also seen that the argument that denies the consequent is valid. And the one that affirms the consequent is not valid. So whose microphone is on?
Who is that? Oh,
Stephen, can you put off your microphone? Yeah. Yeah, that was a brief relief, a sweet music, at least to reduce the pain of these mathematical calculations. Okay, so we've seen that any argument that affirms the antecedent is valid. The one that denies antecedent is not valid. The one that affirms the consequent is not valid. The one that denies the consequent is valid. So when you go home, later on you look at the diagrams again, and then you make your calculations so that you can see them more clearly. Okay, so now based on that, the 4 operations are actually for 2 kinds of arguments, or rather the 2 of the 4 operations that are valid they have their names. The 2 operations that are valid, they have their names. One is modus ponens, the other one is modus tollens. The one that affirms the antecedent, we call it modus ponens. And then the argument that denies the consequent, we call it modus tollens. So let's see how it is. 4 kinds of deductive arguments. So we have modus ponens, an argument that affirms the antecedent. So the one that affirms the antecedent, we call it modus ponens. All A's are B's, X is an A, X is a B. All Ghanaians are Africans, Peter is a Ghanaian, Peter is an African. It's a modus ponens. And we've seen that it is valid. Then we have the fallacy of denying the antecedent. So all A's are B's, X is not an A, X is not a B. All Ghanaians are Africans, Peter is not a Ghanaian, therefore Peter is not an African. So this one is not a valid argument. So Peter could possibly be a Cameroonian. So denying the antecedent, we call it the fallacy of denying the antecedent. Then we have modus tollens. All A are B, X is not a B, therefore X is not an A. So denying the consequent, we said it is valid. We call it modus tollens. If you say Peter is not an African, then automatically Peter cannot be a Ghanaian. It's a valid argument. So the argument that denies the consequent is valid. We call it modus tollens. All Ghanaians are Africans. Michael is not an African, therefore Michael is not a Ghanaian. Okay, so let's check this one. We've also seen the argument about the university. All those studying in the Department of Physics are enrolled at the University of Ghana. Kevin is not enrolled at the University of Ghana, so Kevin is not studying in the Department of Physics. So let's assume that there is a debate. There's a debate about whether Kevin is studying in the Department of Physics or not. Some people say Kevin is in the Department of Physics. Some people say Kevin is not in the Department of Physics. And then someone goes to the registrar to find out whether Kevin is enrolled at the University of Ghana. And then the registrar tells the person that Kevin is not enrolled at the University of Ghana. So what happens to the whole debate? So by denying that Kevin is enrolled at the University of Ghana, automatically you have denied that Kevin could be at the Department of Physics. So this is an argument that denies the consequent. It's similar to the one that says Peter is not an African, therefore Peter is not a Ghanaian. All those studying in the Department of Physics are enrolled at the University of Ghana. Which one is the antecedent? Which one is the consequent? What is the antecedent and what is the consequent?
The antecedent is Kelvin, and the consequent is the Department of the consequent is the Department of Physics, and the consequent is the University of Ghana.
Yes, so the antecedent is studying in the Department of Physics. And then the consequent is enrolled at the University of Ghana.
Yes, it is.
Yeah, so with that sorted out, then you look at the argument. What kind of argument is this? Is it a modus tollens? Is it an argument that affirms or denies what?
Sir, please, it denies the consequence.
It denies the
consequence.
So is
no,
it
denies it denies the antecedent. Therefore, it's a valid argument.
Hey.
Yeah, so it denies the consequence. So that makes it a valid argument.
Yeah.
Yeah, so once you deny that Kevin is enrolled at the University of Ghana, then automatically you can deny that he is at the Department of Physics. Okay. So you can see the two boxes. You see University of Ghana, you see Department of Physics. If you want to deny that someone is in the Department of Physics, all you need to do is to just deny that he's at the University of Ghana. So if you say all those in the Department of Physics are at the University of Ghana, Kevin is not enrolled at the University of Ghana. So Kevin cannot be in the Department of Physics. That denies the consequent. Okay. Then what about the fallacy of affirming the consequent? All A are B, X is a B, X is an A. So let's look at it in words. All Ghanaians are Africans. George is an African. Therefore, George is a Ghanaian. I think we had already identified that this argument is not valid.
Yes, sir.
Yes,
Okay.
sir.
Yes, please, we have.
Okay, so this is a fallacy of affirming the consequence. The fallacy of affirming the consequence. All right. So the consequent Africans contains a logically larger category of denotations than the antecedent Ghanaian. So the fact that George is an African does not necessarily mean that it's a Ghanaian. It may be a South African or a Cameroonian. So if we affirm the consequent, we are not sure we can affirm the antecedent. So you can see the technicality there. If we affirm the consequent, we are not sure we can affirm the antecedent. In short, if we affirm the consequent, it will land us in the same kind of uncertainty that we saw in the fallacy of modus ponens. Now let's look at another form of the fallacy of modus tollens. This one is just, a technical jigsaw. All A are not B. X is not a B. Therefore, X is not an A. Now, so this is an argument that is saying something about the consequent. But the question is it affirming or denying the consequent? Does anybody know the answer? Is it an argument that affirms or denies?
It denies.
Okay, now you don't just look at premise 2 to know whether it denies. You also have to look at premise 1 and look at premise 2 again. Now you can see that premise 1 is negative. Premise 1 is saying something negative about B. And premise 2 is also negative about B. So both premises 1 and 2 are negative about B, about the consequent. In mathematics, you know that 2 negatives gives you a positive. Do you remember that? 2 negatives gives you a positive.
Yes, sir.
Yes, sir.
Yeah, so premise 1 is negative about B. Premise 2 is negative about B. So that means that one negative is affirming another negative. So because 2 negatives gives you a positive, you will say that it is an argument that affirms the consequent. It is an argument that affirms the consequent. It doesn't deny the consequent, it affirms the consequent.
Sir, please, can you say that because the premise 1 and the premise 2 are all agreeing that X is not a B, that is what makes it a positive?
What makes it a positive is that premise 1 says not B. If you look at premise 1, you will see not B. And then you look at premise 2, you see not a B. So you have 2 not Bs. So not B and not B would simply give you B. Do you get the idea?
Sir, please.
Yes,
sir. Yes.
Yeah, so you have 2 not Bs, not B, not B. So it will just be B. Now, when you have 2 nots, when you have not in the 2 premises, just cancel them out. When you have not in the 2 premises, all you need to do is to cancel them out. So you are left with 2 positive premises. Do you understand that?
Yes, please.
If 2 premises are negative, cancel out the 2 negatives and both premises will become positive. Yes, Valerie. Tonu. You had raised your hand. I thought you wanted to ask a question. A champong. A champong's microphone was on. Okay, so now, so we have seen it. So please, you need to watch out for this kind of situation because it could be used to deceive you. If you see two negative premises, you have to cancel out the two negatives, and then you are left with two positive premises. Remember that two negatives gives you a positive. When you have one negative, then you have to work with it. But if you have two negatives, then one negative will cancel the other. Just remember that. So look at it here. All human beings are not goats. X is not a goat. Therefore, X is a human being. So you have not goats, you have not a goat. You have two nots. You cancel out the knot. What you have is all human beings are goats. X is a goat. Therefore, X is a human being. Or you can say all human beings are not goats. X is not a goat. X is a human being. Now, the important thing is that when you see not and not, it is an affirmation. So this is an argument that affirms the consequent. And any argument that affirms the consequent is not valid. So when you want to find out why it is not valid, you look at the sentence again, you look at the argument again, and you see why it is not valid. Now, if you say all human beings are not goats, and something is not a goat, can you, on the basis of that, conclude that such a thing is a human being? We know that all human beings are not goats. That one is certain. But if you say X is not a goat, is it enough to say X is a human being?
No, please.
No, sir.
Yes, so why is it not a valid argument?
Because X can be a tree or a different animal.
Yes, that's correct. That's correct. So the fact that all human beings are not goats doesn't mean that anything that is not a goat becomes a human being. So you can see that it simply works in that way. Okay, so again, not being a goat is a logically larger category than all human beings. So the fact that X is not a goat does not necessarily make X a human being. X could as well be a cat or a tiger. Then we have hypothetical syllogism. Now, so we have seen modus ponens and we've seen modus tollens. And we saw the fallacy of modus ponens, we saw the fallacy of modus tollens. Now, we are now looking at another kind of deductive reasoning. This one is called hypothetical syllogism. This is an argument where the consequent of an initial or first premise becomes the antecedent of the second or subsequent premise. That is, the consequent of a particular premise becomes the antecedent of the next premise. When you see each premise, you see the consequent. That consequent becomes the antecedent of the next premise. For example, all A are B, all B are C. Now you can see that the consequence of the first premise, B, has become the antecedent of the next premise. And you can see that the consequent of the second premise, which is C, it can become the antecedent of a third premise. So a third premise will be all C are D. And then the consequence of a third premise, which is D, can become the antecedent of a fourth premise. So a fourth premise will be all D are what? E. And in fact, you can take it from A down to Z. All A are B, all B are C, all C are D, all D are E, all E are F, and you continue. And then the conclusion pairs the very first antecedent with the very last consequent. So look at the last two lines. The conclusion pairs the very first antecedent and the very last consequent. So look at the conclusion. Therefore, all A are C. The conclusion brings together the very first antecedent, which is A, and the last consequent, the very last consequent. In this case, it is C. But if you elongate this argument down to Z, then the last consequent to be Z, you just bring it. Therefore, all A are Z. So we call it a hypothetical argument. Let's put it in words. All Ghanaians are Africans. All Africans are human beings. Therefore, all Ghanaians are human beings. So all A are B, all B are C. Therefore, all A are C. Okay, so you can even elongate it. All Ghanaians are Africans. All Africans are human beings. All human beings are creatures of God. All creatures of God must go to hell or heaven. Therefore, all Ghanaians must go to hell or heaven. Okay, so the conclusion just brings together the very first antecedent and the very last consequent. So the explanation, we notice that the consequent of the first premise, which is B, becomes the antecedent of the second premise. And the antecedent of the second premise, which is the consequent of the first premise, leads us to a new party, which is C, as the consequent. So it just continues like that. Now, so let's look at two fallacies of hypothetical syllogism. There are two fallacies. The first fallacy, all A are B, all B are C, therefore all C are A. You notice that something changed from the last argument. What is it? What changed from the last argument?
All C are A.
All C are A. That's good. So instead of all A are C, this person reverted it to all C are A. Now you look at it, the argument becomes very funny. Look at this. All Ghanaians are Africans, all Africans are human beings, therefore all human beings are Ghanaians. So obviously this is a fallacy. Then let's look at the second hypothetical fallacy. All A are C, all B are C. So this one doesn't even proceed in a hypothetical way. It just jumps, it can jump, from all A are B, it went to all A are C. All A are C, all B are C, therefore all A are B. So you see that all A are C, all B are C, therefore all A are B. So this is a fallacy. Let's put it in words and we'll see how it works. All Ghanaians are Africans, all Kenyans are Africans, therefore all Ghanaians are Kenyans. So you see it's a fallacy. It doesn't work well. Sometimes it can be true by accident, but if it is true, it is by accident. It is not by design. It cannot be true by design. It can only be true by accident. And when something is true by accident, you should be able to know that it is true by accident rather than by design. Look at this. All Ghanaians are human beings, yes. All Africans are human beings, yes. Therefore, all Ghanaians are Africans. That's true. So this argument is true, or rather, not the argument is true, but the conclusion is true. But the conclusion is true by argument. The argument itself is fallacious. The argument is a fallacy. Now, all Ghanaians are Africans is true, but it is not in this argument, it is not from this argument that you knew that all Ghanaians are Africans. It is outside this argument that you knew that all Ghanaians are Africans. This argument cannot tell you whether all Ghanaians are Africans, because the argument does not contain the mechanism to show you that all Ghanaians are Africans. All Ghanaians are human beings. All Africans are human beings. Therefore, all Ghanaians are Africans. So the conclusion is true by accident, but the conclusion did not come from the design of the argument. The argument cannot show you the conclusion. So if you see this kind of argument, you should be able to know that it is the conclusion is true by accident. And a true conclusion does not make a valid argument. A true conclusion alone does not make a valid argument. If it is in a debate, you can say, yes, the conclusion is true in the real world, but the argument itself is invalid. So that's that about hypothetical syllogism. So that's the second hypothetical fallacy. Now let's look at this. Disjunctive syllogism. This is a syllogism where the main premise is a disjunctive, either or. You know, we have these either or statements. Previously, we were looking at if-then statements, conditional statements, if-then. These ones are disjunctive statements, either or. When we affirm something of any of the disjunctive items, then we have automatically denied it the other disjunctive part. For example, either A is true or B is true. A is true, so B is false. Or either A is true or B is true. B is true, so A is false. Let's put it in words. Either I became a reverend father or I got married. I got married, so I did not become a reverend father. Or either I became a reverend father or I got married. I became a reverend father, so I did not get married. So these are disjunctive arguments. It's called the disjunctive argument. So a little exercise. Determine what kind of argument this is. Anytime he goes to town, he passes by my mother's house. Today he passed by my mother's house, so he went to town. What kind of argument is this? We've seen modus ponens, we've seen fallacy of modus ponens, we've seen modus tollens, we've seen fallacy of modus tollens, we've seen hypothetical syllogism, we've seen two fallacies of hypothetical syllogism. Now we've seen disjunctive syllogism. So which of those arguments best describes this argument? First of all, you need to find out the antecedent and the consequence. If you're able to find out the antecedent and the consequence, then you can determine what kind of argument it is. So what is the antecedent and what is the consequence? Now, in which statement can you or should you locate the antecedent and the consequence?
Anytime he goes to town, you get the antecedent, and then he passes by mother's house will be the coincidence.
Okay, so what's the antecedent and what's the consequence?
He goes to town becomes the antecedent, and then mother's house becomes the coincidence.
Okay, so anytime he goes to town is the antecedent. He passes by my mother's house becomes the consequence. Yes. Okay, so today he passed by my mother's house. So looking at the second premise, what type of argument is it?
Modus ponens.
Modus ponens. Modus ponens is an argument that affirms the antecedent.
Sir, please, fallacy of modus tollens.
Fallacy of modus tollens.
Yes, please.
Yeah, that's an argument that affirms the antecedent. Yeah, so he's correct. It is a fallacy of modus tollens. It is an argument that affirms the antecedent. He passes by my mother's house. Today he passed by my mother's house. So that's an affirmation, affirming the consequence. So it is the argument is a fallacy. It's a fallacy of modus tollens. Now, look at the argument very well and suggest why it is a fallacy. Why is it a fallacy? Why does the conclusion not follow with certainty?
Sir, please, the fact that he passed by my mother's house doesn't mean he went to town.
Okay, so if he passed by my mother's house, he can go anywhere. He can, if he passed by my mother's house, he can just go to the next house. So that's good. Now answer correctly. Sorry, let me mute everyone. Smart Adina, your phone is on. Your microphone is on. Okay, so answer correctly. We deduce correctly when we deny the antecedent. True or false? When we deny the antecedent, we deduce correctly. Is it true or false?
False.
Sir, please, false.
Good. Good. Okay, so
false.
We deduce correctly when we affirm the antecedent. True or false?
True. True. True.
Okay, we deduce correctly when we deny the consequent. True or false?
True. True. True.
Okay, we deduce correctly when we affirm the consequent. True or false?
False. False.
False. Okay, that's fine. Now let me mute everyone again. Yeah, so if I've muted you, please don't unmute yourself. Now let's look at validity versus soundness. Validity versus soundness. Now the four types of deductive syllogism are four ways of making deductively valid arguments. That's modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism. Now a valid argument is an argument whose premises are logically consistent with its conclusion. The premises of a valid argument necessarily imply its conclusion in the manner that it is impossible to deny the inference without running into self-contradiction. So you cannot deny any of the four valid arguments unless you want to contradict yourself. An invalid argument is an argument whose premises do not logically imply the conclusion. So we've seen a few invalid arguments. Now, the relationship between the premises and the conclusion is not that of logical necessity. That's for an invalid argument. You cannot proceed to deny the conclusion of an invalid argument without contradicting yourself. Or, sorry, you can proceed to deny the conclusion of an invalid argument without contradicting yourself. So when you see an invalid argument, you can deny it. If you see an invalid argument, you can deny it without contradicting yourself. If someone says Peter is not an African, sorry, if someone says Peter is an African, therefore Peter is a Ghanaian. Peter is an African, therefore Peter is a Ghanaian. You know it is an invalid argument. You can deny it without contradicting yourself. You can say, oh, yeah, he's an African, but he can also be another country. So you can deny an invalid argument without contradicting yourself. Now, all those fallacies we just saw, the fallacy of modus ponens, the fallacy of modus tollens, That's the fallacy of denying the antecedent and the fallacy of affirming the consequent. And then the two hypothetical fallacies, we call them formal fallacies. Formal fallacies. So that's the last statement on the slide. The formal fallacies, they are the invalid arguments. And it is good for you to appreciate that they are called formal fallacies, because in a few weeks' time, we're going to be doing informal fallacies. So when we start doing informal fallacies, you can compare them to formal fallacies. You will see why they are called informal fallacies. Now, an argument can be valid but not sound. Now, look at this argument. All human beings are immortal. Peter is a human being, therefore Peter is immortal. This argument is valid because it affirms the antecedent. All human beings are immortal. Peter is a human being. So the argument followed the rules for deductive reasoning. It affirms the antecedent, so it is a valid argument. It is valid because it is a correct modus ponens, but it is not sound because one of the premises is not true. Now, the argument is valid, but is it true? You look at the conclusion, you see the argument is not true. The problem started in premise one. You see premise one, all human beings are immortal. So there's an incorrect information in premise one, and then it affected the conclusion. So the argument is valid, but not sound. For an argument to be sound, it has to be valid and also true. If an argument is valid, but it is not true, then it is not sound. Soundness needs both validity and truth. This is another example. All men are mammals. All mammals must get killed, therefore all men must get killed. First of all, what kind of argument is this? Is it modus ponens or tollens or hypothetical syllogism or what? You can convert the argument to symbols and see what kind of argument is this. So men is A, mammals is B, and then getting killed is C. So you have all A are B, all B are C. Therefore, all A are C. So that's a hypothetical argument. But is the argument true?
Say, please, it's not true.
It's not true.
Yeah, so that means the argument is valid because it's a hypothetical syllogism. Any argument that is a modus ponens, tollens, hypothetical syllogism, disjunctive syllogism is a valid argument. But being valid doesn't mean that it will be true. To check if the argument is true, you have to look at the information in the argument. Every argument contains pieces of information. You check the information in the argument, first of all, in all the premises and then the conclusion to see whether all the information is true. So this is a valid argument, but it is not true. Because it is valid and not true, it is not a sound argument. It's an unsound argument. Now we can have an invalid argument with true conclusion. Invalid argument with true conclusion. We already saw something like this before. We saw an argument where the conclusion was true, but the argument was invalid. What was that again? All Ghanaians are human beings, all Africans are human beings, therefore all Ghanaians are Africans. Yes, we saw it. The conclusion was all Ghanaians are Africans, which is true, but the argument itself was not valid. Now, this is another example. Invalid argument with true conclusion. Democracy is better than other forms of political organization because citizens in a democracy are holier than citizens in another form of political organization. Now, this is an argument. This is a single sentence argument. The conclusion is, where is the conclusion and where is the premise? The conclusion is the first part of the sentence. Democracy is better than other forms of political organization. That's the conclusion. And then after that, you have the premise, because citizens in a democracy are holier than citizens in another form of political organization. So this is a single sentence divided into containing both conclusion and premise. The conclusion comes before the premise. Now, look at the conclusion again. Democracy is better than other forms of government. That's true. At least nobody doubts that, most of us believe that democracy is better than other forms of government. So we regard it as true. But what about the premise? Because citizens in a democracy are holier than citizens in other. So is the conclusion true because of the premise?
No.
Yeah, so
No, sir.
okay, so the conclusion, it is not the
No,
premise.
sir.
Okay, that's good. So the conclusion is true, but it is not because of the premise. So you have a true conclusion, but an invalid argument. An invalid argument with a true conclusion. Look at the bottom of the slide. True conclusion alone does not make an invalid argument correct. So when you identify an argument like this, you have to note it. People can advance invalid arguments with true conclusion in real life. And then looking at the true conclusion and without any proper training as a critical thinker or a logician, you will be forced to accept the argument simply because it arrives as a true conclusion. But if you do that, then it means that you have been tricked. It means you've been deceived. So in such cases, you have to say that, yes, the conclusion is true, but the argument itself is invalid. Then we have valid and sound. To be sound, all the premises in a valid argument must be true. All men are mortal. Peter is a man. Peter is mortal. So this is valid and sound. So we have three forms. We have valid and sound, valid and unsound, invalid and unsound. So just to repeat what we just did, valid and sound, all snakes are reptiles, which is true. Cobra is a snake, that's true. Therefore, cobra is a reptile, that's true. And then the argument itself is what? What kind of argument is it? Cobra is a snake, affirms the antecedent. So it's an argument that affirms the antecedent. It's a modus ponens. So it's a valid modus ponens, and it is true because all the information in the argument is true. So the argument is valid and sound. Then we have valid but unsound. All snakes are reptiles, that's true. Mosquitoes are snakes, that's false. Therefore, mosquitoes are reptiles, that's false. So the argument is it valid? All snakes are reptiles, mosquitoes are snakes. Yes, it's a valid argument. It's an argument that affirms the antecedent. Mosquitoes are snakes. So this is a valid modus ponens, but the argument is false. So it is valid but false. We say it is valid but unsound. Then we have both invalid and unsound. All snakes are reptiles. That's correct. Mosquitoes are reptiles. That's incorrect. Therefore, mosquitoes are snakes. That's incorrect. What type of argument is this? Mosquitoes are reptiles. That affirms mosquitoes are reptiles. That affirms the consequent. So this is a fallacy of modus tollens. The fallacy of modus tollens, and it is also false. So it is both invalid and unsound. Invalid because the argument affirms the consequent, unsound because one of the premises is not true. Okay. So is an invalid but sound argument possible? No. An invalid argument is unsound. You can't have an invalid argument that is sound. Even if the premises and the conclusion are all true, the argument will not be sound. So even if you have an argument where all the information is correct, but if the argument is not valid, it can't be sound. Look at this example. All Ghanaians are Africans, that is true. Kofi is an African, that's true. Therefore, Kofi is a Ghanaian, that's true. But what about the validity? The argument is true, but validly speaking, Kofi is an African. That affirms the consequent, affirms the consequent. So it's a fallacy of modus tollens. So a fallacy of modus tollens is an invalid argument, and it cannot be true, you know. Technicality. Validity is needed for soundness. So you can see that soundness needs both validity and truth. Validity is needed for soundness, but soundness is not needed for validity. So validity can stand alone without soundness, but soundness cannot stand alone without validity. Some arguments are valid but not true. Now, soundness needs both validity and truth. Now let's look at these exercises. Identify the missing premise in each of the following deductive arguments. So these arguments are supposed to be 3 sentences or 3 statements, but you have 2. You need to identify the third one. All military men play football. Bob plays football. What's the missing statement?
Bob is a military man.
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 Oh, that's correct. Then all Americans are human beings. All Americans are mammals.
All human beings are mammals.
All human beings are mammals. That's correct. Okay. So answer correctly. Which fallacy is committed by the following? All A's are C's, all B's are C's, therefore all A's are B's. You can put it in words. All Ghanaians are Africans, all Kenyans are Africans, therefore all Ghanaians are Kenyans.
Sir, please, fallacies of hypothetical syllogism.
Okay, that's correct. That's correct. All right, so describe the following arguments. All Europeans are not my friends. Ben is not a European. Ben is not my friend. What kind of argument? If you want to know what kind of argument it is, you can reform it into the one below. No European is my friend. Ben is not a European. Ben is my friend.
So please, the first one is denying the antecedent.
Now,
it's fallacy of modus ponens.
Fallacy of modus ponens.
Yes.
The second one is the same as the first. Or you can say the
Modus
second one
ponens.
is a reformulation of the first. So if you do that, then you are falling into a trap. Now look at them again. No European is my friend is negative. You have no European. The second one, Ben is not a European. So you have no European, you have not a European. So you cancel the two negatives. So, and if you remove negative from premise 2, it means premise 2 is a positive. So without the negative, premise 2 becomes an affirmation. An affirmation of what? An affirmation of the antecedent. And what kind of argument affirms the antecedent? So it's a modus ponens.
Yeah, modus ponens.
Yeah, so just remember that two negatives will give you a positive. Two negatives will give you a positive. So this is the end of the class. We will do the inductive reasoning next week. All right, so any questions? We'll take a few questions before we round up. Anyone who wants to ask anything? Although I think you need a lot of time to absorb what we have said. So even if you don't ask any questions, it's fine. But if anyone has anything to sort out, then that's fine. Okay, so I'm going to upload this video right now. And I'll encourage you to watch the video several times. Tell those who didn't attend the class to watch the video as well. All right, so I wish you a very happy weekend.
You too, sir.
Thank you.